Okay, everybody, I'm just going to make sure we are actually live right now, so give me a second. Welcome to a IAEI News Live. Yes, we are. Welcome to IAEI News Live. Today's Tuesday. My name's Thomas Dimitrovich. I've got two individuals sitting in the waiting room right now, waiting to get on and tell us about some great things happening with arc fault circuit interrupter technology, moving the ball forward in electrical safety during Electrical Safety Month. So we have Donnie Davenport and Ashley Bryant from Ashley is from Siemens, and we're going to introduce both of these individuals here shortly. But we're going to talk AFCIs. We're going to talk about AFCIs during Electrical Safety Month right here, IAEI News Live, and it all starts now. All right. We've got Donnie Davenport and we got Ashley Bryant. Welcome to the program, guys and gals.
Thank you so much, Tom.
Excellent. Yeah, it's really good to see both of you. And I know, we got Joseph Violi and Larry Griffith out there, guys. And thanks for tuning in. We got Felix Sandoval from Colombia, South America. Good morning, everybody. We were sitting in the background chatting away, and I'm like, oh my gosh, it's 12 o'clock. So we must push the button and went live, and that's what I love about being live. So Ashley and Donnie, thanks and welcome to the program. So what I'd love to do, because I doubt anybody has seen your faces on this program, and what we'll do is start way over there on the other end with Ashley. So Ashley, why don't you do us a favor and tell us a little bit about yourself?
Okay. Hey, everybody. My name is Ashley Bryant. I work for Siemens. I've been with Siemens since 2001. I am the product manager for electronic circuit breakers. So I cover the arc faults, ground fault, and dual function circuit breakers. I am also the co-chair of the NEMA AFCI Interoperability Task Force Group and the co-chair of the NEMA AFCI Promotional Task Force Group. I've been working specifically with the AFCI's product management role for the last 10, 11 years or so. And I am so happy to be on the program today. Thank you, Tom.
Awesome. That's perfect. And I forgot that you are heavily involved with the AFCI task force. I know I sort of veered away a little bit, but really glad to have you here. Thank you for all you do for electrical safety. And Mr. Davenport, why don't you give us a little bit of your background, buddy?
Thanks, Tom. My name is Donnie Davenport, and I'm an electrical contractor here in Denver, Colorado. We do new construction, residential wiring primarily. And so we install an awful lot of these arc fault breakers all over the state. And we've been doing this since the middle of the 80s. And we are we're happy to be here today, Tom. Thank you so much.
Excellent. So what state are you in again?
Denver, Colorado.
Oh, Denver. Oh, Denver, Colorado. That's where it gets a little bit cold, doesn't it?
Yeah, a little bit.
I did. We were out there a while ago, and I think that's where I did snowmobiling. So very, very nice. We were up looked at the Great Divide. That's pretty cool. Yeah, it's pretty nice. Very nice. So AFCIs have, Ashley, I think sometimes I wonder when we stop talking about AFCIs because they've been around so long, and you wonder, you think about the history of just the technology. Circuit breakers and receptacles and fuses have been around for ages. And you would think that, well, what can you possibly do to some of this technology to make it better? And we start adding technology inside of these small little enclosures and put a little brain in there, and you take that product to a different level. So we added GFCIs. I think that would be the first thing, right? We added the GFCI technology to both a receptacle and a circuit breaker. And now we have an AFCI technology. And is there a difference between AFCIs and GFCIs? Think about.
Absolutely. Yeah.
How would you?
Yeah. So we added the GFCIs were back in the 70s, right?
Yeah.
And those were specifically designed to protect people from being electrocuted. Basically, the technology on the GFCI is what goes out must come back in. And if you've got anything leaking, let's go ahead and shut that power down so we don't electrocute somebody. And that's the purpose of the ground fault technology. And then was it sometime in the late 90s was when they said, well, we've seen an increase in the number of residential fires, home fires, and let's try to figure out a way to protect the people and the homes.
Yep.
And the babies and the puppies. And so that's where the arc fault technology was born. And it was a device specifically designed to shut the power off if it detected any type of electrical arc or spark in the circuitry.
Yeah. And so there's, the question that comes up often that I've seen is the compatibility between GFCIs and AFCIs. You have an GFCI receptacle downstream of an AFCI circuit breaker. I've actually heard, and I don't know, Donnie, if you've seen this before, some people, and I've actually seen this, electrical contractors like in a garage, put GFCI receptacles feeding other GFCI receptacles, for not realizing that the GFCI receptacle protects downstream, just like an AFCI receptacle would do, and it all looks downstream. So once you have that protection higher up in the system, it protects everything downstream. Yeah. But have you ever seen any compatibility issues, Donnie, with like even GFCIs downstream of GFCIs or anything like that?
I can't speak to any of that specifically. No, we have our practices as to how we install and usually try to make sure that we don't have that situation happening. Yeah,
you do it the right way.
Yeah,
that's it. That's the key. And Ashley, you talked a little bit about this when you said about the journey that the technology has taken. And I know I used to have a slide somewhere that sort of laid out and showed how technology has changed over the years. And AFCIs actually were introduced, I believe, with the 1990 code.
1999 National Electric Code. They were introduced with a 2002 enforcement date, effective 2002. And initially, these devices were only required to protect the bedroom circuits. And then over time, we learned that these devices actually do work and they do their job. And hey, if we're going to protect the bedroom circuits, we might as well protect the dining room and family room and closets. And I think the next slide, Tom, lays out all of the, there you go. All of the different areas of the home that are required for AFCI protection, and this is per the 2020 code. Family rooms, dining rooms, living rooms, parlors, libraries. Basically, almost every room of the house is required to be AFCI protected.
Yeah, and I remember watching the discussions at the code making panel over the years that when they started in bedrooms, the misconception that I've heard is that the reason we started in bedrooms is because that's where people die. And the reality of the fact is, I mean, that is a reality, unfortunately, because of smoke inhalation, you're sleeping, and a lot of these fires, electrical fires, start behind the walls. So you don't know they're going on until it's too late, and you get a lot of smoke inhalation. And at night is the worst time. But they started in the bedrooms because they wanted, and there was a concern about compatibility. And they thought the least exposure was that bedroom circuit. So they initially started in that bedroom circuit with the vision that they would be throughout the residential home, because the fires that we're starting that we're trying to protect from were those that were in that NM wire that's behind the walls, right? And it's that journey of the wire through the entire structure that you need to protect, right? We talk about what are the possible causes of damage in the power distribution system in a home. I don't know about you and Donnie. I'm like one of I'm one of those homeowners that you probably go, oh, because I want to hang my own cabinets, right? And when I hung my cabinets in the house I built, what I did to figure out the screws, right, the wood screws to put these cabinets on, I figured I got a 2x4 this big. I got drywall that's about this thick. So I got a screw that I knew just wouldn't penetrate and come out the other side, because I wanted that puppy all the ways in that 2x4. And as an electrical contractor, there's a discussion point. So when you lay out where you're going to route wires, like say in a kitchen or a dining room, do you think about where people might be hanging cabinets on the wall and think about like where you want to route the wire to anticipate that?
Absolutely. When we're laying out the placement of the wires inside the wall, we do take all of that into consideration as to how the room's going to be used, and possible furniture and pictures and TVs and things of that often come into situations where we find where we have a wire that's been damaged from somebody hanging something on the wall, for sure.
Yeah.
And try to eliminate that so we can route our wires clearly away from that.
Okay, so how about now new construction? You said you do a lot of new construction, right?
We do.
Okay, so how about order of the trades coming into that structure? The HVAC, the plumber, do you want to be there? Do you want your wires in place before the HVAC guy and the plumber? No.
No, it's really important, and it's extremely challenging right now with everything going on with the environment and new construction and materials that every trade is running into, having problems. And a lot of times we do find where the builder's pushing on the schedule trying to get electrical installed because we're the last one to get them over the finish line into final inspections. And they're in a hurry to get us in. And if one of the other trades comes in afterwards and they install something, it's easy for the wires that we have in place to get damaged. And it's a challenge every day dealing with that, for sure.
Yeah, that and the only reason I knew that was because of my house. That's the problem that we had. I built that house, and my electrical guy showed up, and he pulled me on the side. He goes, listen, he says, they want me to pull wires. He goes, but your HVAC and plumber haven't been here. He says, this is not a good idea. And I didn't know what to do. So I'm Joe homeowner, right? So, and he put his wires in, but then I was there when the HVAC guy was there, and I watched him tugging on the wires to put his ductwork between. Yeah. Boy, I tell you, I cringed on every one of those circuits. Ashley, what were you going to say?
Oh, I was just saying I had spoken to an electrician one time who told me he used to wire his wires around door frames until the arc fault breaker came out and caught him because the nails of the molding around the door frames were going through his wires, causing the breaker to trip, and then he had to adjust where he ran his wires after that.
Yeah. And it takes time.
It's just it's a change. We're kind of same thing with GFCI back in the 70s. There was an adjustment period, and same thing with the AFCIs. There's been an adjustment period, just trying to learn new tips and tricks. And I mean,
you're right. There's, like you say, it's a progression. You've got the code panel's realizing, or the code panel's journey was, look, we want to hit all of these circuits, realizing that it's not just a bedroom circuit. It's not a problem that's in the kitchen or in the living room. If I look at all those lists of all those areas, it's the journey of that wire from when it leaves that panel board and goes to the loads. And just like in GFCIs, okay, we had this discussion on panel 2. We use the distance of a receptacle from a sink as a measurement point, right? We use the areas inside of a home or a structure to identify a requirement. And it's not necessarily because the receptacle is a bad thing. It's what's plugged into the receptacle that is. But it's hard to say. It's hard to take and say, look, but beside every lamp, we need you to have this. When you don't need, you don't know where the lamps are going to go, right? So you've got to write code that an inspector and a contractor knows how to enforce and how to follow. Mm-hmm. And so we key things off of rooms. When it comes to AFCI, we key things for GFCI, the proximity of a receptacle to a sink. Not that the receptacle is going to kill you. It's what's plugged into the receptacle, right? So we key off of these rooms, and the continued expansion, I'm sure presents some challenges for guys like Donnie and contractors when you get into the panel board with all those pigtails and all of those. I wired up a few panel boards myself with some contractors, and you got the pigtails, and you got to get all the neutrals to one bar, you got all your grounds to another bar, and then depending upon where you put them, it's like, well, how do I get this neutral? How do I get this pigtail from this breaker all the ways over here? So now you are extending those pigtails. Right. And I've gotten those questions. Can you extend a pigtail? Can I cut off of a pigtail and make it shorter? Right. And all of those questions is perfectly fine to do that. But Donnie, you're seeing a lot. I'm sure you've got to be seeing challenges with regard to space inside of panel boards.
Absolutely. Every day it's a challenge to find enough space. You got municipalities too that are getting more restrictive as far as the number of openings and what they consider, how many you can have on a circuit, and panel board space gets chewed up really, really quick. And so, without, hanging panel, your main panel with a meter, and then you got a sub panel and then a sub panel in the basement. And then, it's real easy to get into this, situation where on just a average size home, and you've got to, configure all of these different gear, panels, and it doesn't always look really appealing on the exterior of the home where it has to come in, and you have a lot of different considerations. And so absolutely, the size of the breaker, the pigtails, how all that gets configured inside of the panel becomes a real challenge for us at times.
Yeah. And it's people like Ashley and manufacturers who can try to bring solutions, which, Ashley, I know you have an interesting solution to try to help on a couple fronts, right?
Yeah.
Which we're going to get to as well.
Yeah. One of the things that all of the manufacturers have done is we went to the plug-on neutral.
Yeah.
We can talk a little bit about that. That was kind of a first step. You were talking earlier about all the grounds and all the neutrals and all the load wires coming in, and now you have all of these pigtails that you're having to add onto the load center. And I'm sure Donnie has seen, and we have, Tom, you and I have seen you open up a panel and it looks like a rat's nest going down the gutters on either side of these breakers, with all of the wires that we've now added with the AFCI and the GFCI technology. Because you've got to have some type of power to the brains of the breaker. And that's what that pigtail, that neutral wire provides, is the power for the brains. And now we have the plug-on neutral load centers that all of us carry now, right?
Yep.
And this was a design in order to remove that pigtail. So what we've done is we're running neutrals down the inside of the interior of the load center, and your breaker now plugs onto that neutral bar, and that's where you get the power for the electronics.
Is that right
And then-
here? Is that these two shiny pieces here?
Yep, those two lines that go straight down.
Okay. Go ahead. I'm sorry.
Yeah, no, that's perfect. And so you've got a breaker that's got a neutral clip that plugs onto that, and then it's got the load clip that plugs onto the load side or the line side, excuse me. And so you've got your line power, you've got your neutral power powering your electronics, and now you don't have all of those pigtails. So that is demonstrating the pigtails coming out, and now you're plug on neutral.
Okay. I was wondering. I was looking at all those little white wires. I'm like, wait a second, and I'm thinking, am I
Like,
showing the
wait a
right
minute, there's
video?
still a bunch of wires there.
Yeah. Now I get it. All right. So yeah. So there you go. So you're plugging in now that you made two connections there. You made this is your bus connection. That's where you get your primary power, and then that was the connection into the neutral. And like you said, all your panel board, all your circuit breaker manufacturers have this technology, which, I mean, I remember when we did that, we talked about doing the Les Nessman, let's get some pigs, but we said, no, we can't do that. We're not going to surgically remove some pigtails. So that would be ungood. But at least I think Les threw turkeys out of a helicopter, didn't he? In WKRP in Cincinnati. But yeah, so you remove that extra wire, and the other thing is these breakers from it always bugged me. I'm like, sometimes I can be very I don't know. I like when you sit down and say, okay, I'm going to bring a hot wire in. I'm going to bring this black wire. I'm going to bring this white wire in, and I'm going to land them on a lug. But with a standard thermal mag breaker, you land that hot wire, and then you put the neutral over on some other bus somewhere. And I'm always like, I want to keep them both the same length, right? But the neutral bars in some of these, they're up higher, and then you can cut those neutrals shorter. But then I'm like, well, it's hard to put wire back into a house, So, I would always look at that and watch people curl them up or cut them nice and short. And then, inevitably it happens if you're going to put an AFCI in after the fact. And it's like, I got to bring that neutral now to the circuit breaker. And I think it's so clean. You bring that hot neutral right into the circuit breaker, and it just, I don't know. I think it just cleans up the trough, and then you're very certain, because the other aspect of this, I don't know, Dawn, if you've seen this before, sharing neutrals, right? And knowing which hot conductor goes with which neutral, we bundle them all up and we tie wrap them. And then when you want to get a circuit out, it's like, well, how the heck do I have to unbundle all of these neutrals? It's a pain in the rear end. But
Yes, it is.
So I will say with Siemens, with our new AFCI, the arc fault breaker, the plug-on neutral, we actually took that neutral lug out. So now with the AFCIs, you can wire them just like you used to wire the magnetic breakers.
I didn't know that. So you don't land the neutral on the breaker?
Not on the AFCI.
That's interesting.
Now, dual function and ground fault still have the differential. So you need to
Gotcha.
to land neutral, the load neutral onto the breaker, because you have to complete that circuit. But for the AFCI, yeah, you can run all your grounds, run all your neutrals, and then put all your loads into the breakers.
Well, that probably even cleans that up even more then. Wow, that's really nice, because you don't have ground fault protection inside of that breaker, so you don't care about that extra neutral. Very good. Very good. That's interesting. I like it. You must love that, Donnie.
I do. When you start getting, the ease of installation, and, for us, when we're dealing with the track home, time is money. And so when it becomes simple and clean and easy to install, that's really, at the end of the day, for us, it eliminates confusion and problems and troubleshooting later on down the road when you go to hot check. It just simplifies the whole process of installation and keeps everything really nice and clean inside the panel. Yeah.
And one thing I've learned about electricians you know, they love to see their work nice and neat. I guess it's certain electricians, most of them. But I've also seen some other that don't really care that much. Just saying.
It's hard because everything gets covered up inside the house behind the wall, you know, and we put all that hard work into it. That's the one piece of pride we have, is hanging in that panel.
I know. You know, and I was at a grow facility near Pittsburgh here, and we were walking through their facility, and he was showing me, you know, it's a heavy LED process thing, and there was the gentleman who was walking us around. He was showing all of the conduit and everything, because he bent most of it, right, and he put most of it in, and he built all of the industrial control panels. And he wanted to show me them. I mean, it was like he wants to open the doors up, and I'm sitting there like, "Whoa, is that energized?" You know? He's like, "No, this is not energized." I'm like, "Well, okay, I feel a little bit better now, but you know, I don't want to get exposed to 480 volts or whatever, right?" So, and you got arc flash concerns and a whole safety aspect of it. But you know, he was just so proud to open that door, and I mean, and every wire was perfect. And everything was color coded correctly, and everything was tagged. And you could tell this guy spent a lot of time putting that together. But, you know, to your point, what do? We cover it up. You know, Ashley, when are we coming out with plexiglass covers to show all the great work that these guys are doing? You know, we should arc resistant plexiglass. We got to come up with that.
That's right.
I'm just saying.
We should mention, Tom, because we've talked a little bit about playing with electricity, and it is Electrical Safety Month, that we should always refer that work to a licensed electrician.
Absolutely right. Yes, qualified people. And if anything is fabricated, like this gentleman at that facility, he was making industrial control panels. They were all 508 listed. So he had he was doing them in a panel shop, all that good stuff. So never do your own. You don't want to do your own work with electricity, right? And unfortunately, I don't know what it is. I think nobody wants to do like things like plumbing, because you can let the water out and it'll just destroy everything because you can see it. Nobody can see the electrons, you know? So what we have to do is we have to figure out a way to. Well, there is a way for people to see electrons, and that's what the AFCIs are there to stop, right? And detect. So now Felix Sandoval had a question. Do you think in construction projects based in masonry and concrete with wiring methods based on raceways, things are scrolling, based on raceways, mainly PVC embedded, AFCIs should be required? So
I can touch on that. The National Electric Code 210.12 A, B, C, D, E. Is it E?
I think
says if you wire that home run in 2 inches of concrete, you don't have to have that AFCI protection.
Yeah, because so here's two things though. You don't need the home run in, right?
Oh, all of it.
Yeah, you don't need the whole thing. So, but you have those connected cords, and to Felix's point, Felix is in Colombia, right? So, and different countries, construction of the buildings are different, right? Even in the United States, there's variances on how, like in my basement is block. I'm sure you see a lot of poured basements, right? Or you might see that if you have basements. I mean, if you're in Florida, you definitely don't have a basement. So, but to Felix's point, you may not need to protect the circuit that's going out to that first receptacle, but connecting to anything that's plugged into that receptacle is still subject to being damaged. You know, all your connected cords, your extension cords, things of that nature, appliances and whatnot. So, Donnie, have you found, I don't know what your experience is, but have you found like problems with appliances that have caused AFCIs to trip, and then you've said, hey, this is just bad?
Absolutely. We see it all the time where you have an appliance that has an issue that is causing arc fault tripping. And So I agree that, anything that's plugged in, you still need that protection.
Yeah, and that puts you in a tough spot, though, I'm sure. If you have a homeowner that says, hey, I've been using this vacuum for 20 years and now you're telling me it's bad,
That happens all the time in
Yeah.
homeowners moving into new homes that left homes that were built in the 80s, and they have appliances, vacuum cleaners, washing machines, all kinds of appliances they bring with them. And they just don't understand, because, for years they were able to live that way and never had any issues. And it's not easy to explain to a homeowner that, look, you're in a home that's safer now. What you've been doing is not necessarily, safe, and
Right.
and this is going to make it safer. But it's a challenge, and it's something that it takes time and experience to be able to know where to look and how to identify and nail down what appliance is actually causing the issue.
Yeah. That's a whole troubleshooting experience, right? Of trying to figure out breaking down the circuits and whatnot. Now, Vincent Coley asks, do the combination AFCI, GFCI breakers get wired the same way? And Ashley, I think you touched on that.
I did. So the dual function or dual purpose circuit breakers that have the AFCI and GFCI technology in them, those have a hot lug and a neutral load lug. So 2 lugs. So your hot wire and your load neutral have to come to the breaker.
Yeah.
The reason that is because there's GFCI technology in the breaker, and the GFCI is measuring what goes out must come back in, and you've got to complete that circuit in order for that technology to work.
Excellent. Good question.
That is a good question.
Yeah, good question. And Felix, I think Felix has given us the thumbs up. He says AFCIs go with what is connected to them also. All right, so we're at the bottom of the hour. So do you want to talk a little bit about, before we get into other discussions, because we haven't gotten to AFCIsafety.org, we haven't done all these things, but here we are, 12:33. So I'm thinking that maybe there's a little video we want to play.
Yeah, let's do it.
And do you want to talk about it, talk us through it?
Sure. We talked a little bit about space and AFCIs taking up a lot of space in our panels. And one of the things that, one of the new technologies, the new devices that Siemens launched this past year was the Tandem, or in some areas they call it the Twin AFCI. And here's your plug-on neutral, and you've got your pigtail. So you've got 2 different options for the Tandem AFCI.
Okay, so one has a pigtail, one doesn't. But when you say tandem, and I know there are probably a lot of people out there know exactly what that is, but you've got 2 breakers in one?
Yep, that's exactly what we did. We put 2 circuits into 1 breaker, and now you don't have the current limiting rule anymore. So you can take out a single pole breaker and put in a tandem, and now you've got 2 circuits. So the pigtail breaker can go into any of our older panels, so our Murray, our Siemens, ITE, Gould, Siemens Alice, any of our older panels. And if you're doing any type of renovation, you can pause that real quick if you don't mind. If you're doing any type of renovation, the pigtail breaker is going to be really good for those, the legacy panels. And as you know, if you are adding on any circuits and your panel's already full, what a pain to have to add a sub panel. But now you don't have to do that anymore. You can just get yourself a couple of these tandem breakers, take out your single poles, add in your tandems. Now you've got some extra circuits, and you don't have to add a sub panel. We also offer it in the plug-on neutral for those that need, for whatever reason, a smaller load center, or you need some more space. You can put the plug-on neutral AFCI into the plug-on neutral load centers that are available on the market today. And then this is a new feature that we added, and it's only in our Tandem right now, but we're slowly going to introduce it to our other breakers. And it's one that our electrical contractors have really liked, and it's these lug wire indicator flags. And basically it's a yellow flag that comes up over the screw. And once you insert that load wire or that load neutral for the twin AFCI, you've got 2 loads because you've got 2 circuits. Once you insert that load wire, that flag it's a mechanical, it just pushes back up into the breaker.
Yeah.
And what it's doing is it's indicating that, yes, you have wired that breaker correctly. You've put it in the right spot. A lot of times it's dark when these guys are working. You've got, 4 inches of gutter space that you're trying to finagle that wire into, so you can push that wire in and that flag disappears, indicating, yep, you've got it in the right spot, and now you can tighten down your lug.
Wow. What do you think of that, Donnie?
I think it's fantastic. You know, it's this breaker has given us so many solutions to problems that we've had for years. You know, that indicator helps us to know that the wire's in, you know, you can have a wire in you know, and electricity going across, but you don't have it properly connected to the lug, and then you apply a load to the circuit, you know, and then all of a sudden you start getting a problem with that circuit. So again, from a time and efficiency when we install, you know, knowing that flag has gone, you know, and you can do a visual check to know that the wire is installed where it needs to be. We're not going to have any issues with loose wires or wires not making connection in that lug. So that's a great thing.
Yeah, I know sometimes it's hard because you might not be in the jaws and you might be under, and I know I've seen that. In fact, I've had that whoever did my panel board a long time ago made that mistake, and I was making enough connection. The conductor made enough connection that it actually supplied power, but it was creating a hotspot. And the only way that I found it was when we were in that panel board, and I had the local electrician come in to do, I can't remember what he was adding. He took the cover off and he just pushed on the wires and it just came out. He's like, this isn't even in. So I'm sort of liking that myself.
But to your point, you know, you were in the house for a while, and that was something that was actually, you know, carrying electricity for a period of time, and then created a problem for you later. And you know, for us, that creates a warranty work order that we don't get paid for to go back to. And so the fact that we can have that at the time of installation and know, you know, that it's installed properly, and we're potentially eliminating a call for us to go back to a home, and inconvenience to the homeowner, and, you know, costs us time and money to roll a truck out to a home. Yeah.
Now, Ashley, help me here. I'm looking at a screw with a slot and a square. I mean, what's going on with this? Help me. Is it just a poor graphics designer, or is it designed that way?
It's designed that way.
It is. That's pretty cool. So is that for the screwdriver for a square bit?
Yeah, you can use a square bit, or you can use a flathead.
Or a flathead. What do you?
I think y'all use the square bits, right, Downey?
Yep.
You like
most of the time, yes.
You like those, huh? That's a good connection. Makes it nice and tight.
It is, yes.
Excellent. Should I continue playing, Ashley?
Yeah, sure.
Awesome.
Thank you. Yeah, so Donnie, if you want to touch a little bit more on the Tandem AFCI and how y'all have used it in the field. This is a demonstration of two single pole breakers, and now it's going to go through and take out the single poles and add in the tandems. It's just showing you the space savings.
Yeah, we've been able to, when we bring the tandem into play with the homes that we're wiring, it really helps us in a lot of situations. We were able to, get a smaller panel, use a smaller panel. Sometimes the larger panel board size only comes where you have a meter socket that's separate, and then you have the time and installation of having somebody, wire up the loop wire from the meter socket over to the panel feed that. And there's time, layout, and then, making sure that everything is installed just so, we're able to, most of the time, you can go back to hang an all-in-one panel. By using these tandems, it gives us enough space in the panel that, it saves us time and makes the exterior of the home look much cleaner by eliminating some of that gear that's there on the side of the home. So for us, the size of the breaker inside the panel is really nice too. It's smaller than some of the other fault breakers that are out there. So when you're, in the gutter space, you've got a lot more space where you're trying to get inside there to, to connect the wires and everything. You have more room in that gutter to be able to get everything attached. Sometimes we'll have a home where a builder builds a home as a spec, and then a buyer comes along and they want to add a finished basement. And if we have a panel that doesn't, we're all filled up, and we can go back and we can condense some of those spaces in the panel by taking out a single arc fault breaker that only has one circuit, and we can put this tandem in place and free up enough space in that panel in order for us to be able to get those circuits in and not have to hang a sub panel somewhere and feed it separately. So there's a lot of benefits to us that we found, and being able to look at the size of the home, the number of circuits that it's going to take, and then really we're able to dial in to get the exact size panel that we want with the number of circuits that we need, and it's a real cost savings for us to be able to look at that and design each service for each home specifically.
Yeah, that makes a lot of sense. It makes a lot of sense.
Awesome, Donnie, thank you. I can talk about how cool I think it is, but it's really nice to have a highly respected electrical contractor from the field talking about the features and benefits. I appreciate you.
Thank you.
Awesome. We do have a couple of questions. Felix Sandoval says these are two circuits on one breaker, which it is, on the same phase.
That is correct.
Yeah. So
you cannot share a neutral with these.
Right. And he also asks, tandems are only for plug-on neutral, ? And that's not true, right?
Correct. That's not true. There's we offer it in the pigtail and the plug-on neutral. So we've got the plug-on neutral tandem breakers that you can put in the plug-on neutral load centers, or we've got the pigtail breakers that you can put into Siemens, Murray, ITE, Gould, Siemens Alice, any of those older legacy load centers.
Right. Okay.
Were there any other questions?
I think that's the only. I think that was the only three there. In 210.12, it mentions the circuit is extended 6 foot. How is that supposed to be measured? As the crow flies, overall cable length? That's Willie Snyder. So in 210.12, when you talk about the extensions, you're looking at the length of the conductor, and we added some clarity. And I'm not sure if that's in the 2023 cycle or if it was.
I think it's getting added into the 2023, Tom.
Yeah.
But yes, it's basically the length of the conductor is how it's measured, right?
Yep. And we removed in the 2023, we're making it clear that you don't count the length of the conductor that's in the box.
That's already there.
It's already, yeah. So it's just it's the length of the conductors from when it exits the box and it enters the other enclosure. So we're adding that clarity.
Awesome.
Ashley did not mention, yeah, she didn't. That's okay, Felix. All right. So, okay.
Are we done with the twin? Because I would love to talk about safety.org.
Yeah, let's talk about AFCIs. So what do you mean, Ashley? What is safety.org?
So AFCIsafety.org, because we are in the middle of Electrical Safety Month, so we have to talk about AFCIsafety.org. This is a website that it's a NEMA website put together by the the manufacturers of arc fault circuit interrupters. And this website provides a plethora of information on AFCIs. Not only does it provide some white papers and some basic information, some history of AFCI, and there's some links to a UL training course that is admittedly like a 2-hour training course, but it is, if you are looking for more information on AFCI technology and how it works, it's a great course to learn about the AFCI. Also on this website is a resource for homeowners, for professionals, and most importantly, a link to unwanted tripping report. Oh, you're clicking through, sorry.
No, that's fine.
But I wanted everybody to be aware. There's actually 2 really great resources on this website, right? One is all of our tech support phone numbers. I think if you click on homeowners.
Yep, I'm going to go to homeowners, and
I think.
Is it the homeowner's guide? About us. There's useful links. What do you want? There's the tips, cost overview. Isn't there a?
Well, yeah, there's a page.
Looking for it because there's a breaker types. There's all of the different. So you have ABB, Eaton, General Electric, Siemens, Square D. So all of those are represented. And if you can contact any one of those manufacturers with any questions, right?
That's right.
So you can enter your name, your email, put your message in. So that's one way that if you want a specific manufacturer to call you back on something, you can do that through NEMA, because NEMA is that nice umbrella for us.
That's right.
And there's the homeowner guide, which helps you understand the proper use and what AFCIs will do for you. And wow, like there's your hire a professional. Okay.
Please.
Yes. Yep.
There you go. I'm sorry, Tom. Click homeowners and then tips.
Oh, tips. There we go. Oh, there we go.
Okay, so right there is one option. We've got a bunch of 1-800 numbers. You can call our tech support teams, and I can tell you all 5 of us have incredible tech support teams. They're very familiar with the AFCI technology. They're well versed in what we're seeing in the field. I feel so good about where we've come. Tom, we talked about how the AFCI technology has been in the field now 20 years. Yeah. This is our 20th anniversary. And at first these things caused a lot of people some pain, and it was a change. Yeah. Nobody likes change, but having, like we talked about earlier, you can't wire around door frames anymore because that's going to cause a problem and those kind of things. But once a lot of those different practices changed, really we're not seeing the interoperability issues in the field that we were in the beginning. But if you do have any that you're having trouble with, we have provided here our 800 numbers. And if you would prefer do an online ticket, we have a button called Unwanted Tripping Report. And on this button, we offer 2 options, either the AFCI report, AFCI safety report, or the AFCI safety receptacle report. And that's it's AFCI, one goes to the breaker guys and one goes to the receptacle guys. But in here, you put all of your contact information and then, kind of specify what your breaker is, what's on the circuit, what's going on. Those reports come directly to us. And then we'll give you a call or send you an email and help troubleshoot any issues that you're seeing in the field. We want to make sure everybody knows that those resources are available for you because we want to help. All of us want to help with any issues that are going on in the field. We don't want these things to cause you guys headaches.
Yeah, and well, Ashley, what I like about the form, and I remember when we put this together a while ago, it guides the contractor. I always tell electrical contractors, especially in the world of AFCIs and GFCIs, because, you know, that's where these types of technologies are unforgiving. They count the electrons, right? They're looking at what goes out, got to come back. And if it's not coming back, and sometimes it's easy to just shoot the messenger. But troubleshooting and walking through a process, or if I was in Canada, a process to say, here are the things I need to do, and think about, these forms help guide the individual to capture as much information as we can. And I always tell people, if you're troubleshooting these circuits, don't spend a lot of your time before contacting the manufacturer, because, you know, even if you sit down and say, like, for example, I had a problem in my house here. I had a Gfci circuit breaker that was tripping on a living room circuit, and I didn't know what was going on. So we talked to my electrician. My electrician contacted my guy back at our headquarters, and he gave him some ideas on how to break the circuit up. And we ended up finding the problem, and it was a stripped conductor that went from the inside to the outside to an outside receptacle. But the techniques of how to troubleshoot, some people may not be as good at troubleshooting as others. You know, I want to go straight to the end game, but there are a lot of people that say, look, you know, there are a lot of people that just enjoy the whole journey of trying to find a problem. And there are people like me who hate that journey, right? So, and I always say, Donnie, and you can confirm this, I say, Donnie, there are two types of electricians. There's those who deal with new construction and those who deal with existing homes. The guys who deal with new construction, they don't want to work on an existing home. And then there's the guys who do the existing homes that don't want to see a builder ever in their life because they enjoy that aspect of it. And it's rare to find the one who loves to do them both.
Absolutely. I would agree with that. And it's something that, you know, if you're looking for an electrical contractor, to make sure you understand, you know, what their skill set really is, because you can hire somebody that you think is qualified, but might let you down because they're just in an environment that they're not familiar with.
Absolutely. And look, David Engelhardt believes in AFCIs so much, he dialed in from Waikiki on his vacation. Thanks for joining in.
Thank you.
Yeah, absolutely. So we have a homeowner information. We have professionals. So this would be, I guess, for contractors, state adoption. And there's that UL training course that you were talking about. And we put that together because of what we were just saying about what Donnie just said. Some people don't have that. Some people say, look, you know, I don't like troubleshooting. I'm not good at troubleshooting. And that educational program that we worked on with UL breaks it down to help people understand some of the thresholds, like series arc detection starts at 5 amps. And the parallel arc detection starts at 75 amps, that you might need to put some load on the circuit to get that breaker to say, oh yeah, I see a problem. Because a lot of people say, look, I turned the iron on and it tripped, and they blame it on the iron. But the iron just added enough current so that the actual problem, which is elsewhere, manifested itself. So
yep.
Gotta love it. But
yeah, I had that problem in my house. My older house, we had some AFCIs in there, and I had a really cool lamp I had gotten from my grandmother. And when that lamp was on, there weren't any problems. But as soon as I started to vacuum, the breaker tripped. And you know, I thought it was the vacuum, of course.
Of course.
And after doing some troubleshooting, determined it was actually the lamp. The wiring was loose inside the lamp. You know, homeowners, we bring all sorts of stuff into these houses.
Oh, absolutely.
The lamp itself didn't have enough load to really give you the problem. You needed more load in order for the problem to become apparent.
Yeah.
Exactly. Yep.
Yeah.
Now there are some cool videos that NEMA has on the multimedia tab. Now what you've identified and I love this presentation because we all talk about the tripping issues and things that occur, or we show the electrical fires where there was no AFCI protection, right? This presentation goes through the success stories on why we do what we're doing and all of those areas where the AFCIs detected a problem. Electricians like Donnie spent the time to find it and probably didn't get paid for it. Or maybe they did, especially after you find the problem and the homeowner gives you the big hug, and you go, we did it. We figured it out. And then they realize the magnitude of what could have happened. These are all, like this one right here was out of South Carolina. And I know this one personally because this individual contacted us. They drilled through a gusset plate by mistake, pulled that wire down through. The entire wire was stripped, and not only was there an arcing going on, but there was a gas leak in that attic. And the homeowner did not want to just replace it with a thermal mag breaker. He worked with us. We worked with his electrician, and they found the problem, and he was so elated. We did some videos with him. We put those up on YouTube. Those are all available, and we share his story, Mr. Chioda's story, all the time. But this presentation, this material is free for a download off of the AFCI safety website. So, and if people have examples of where an AFCI found a problem, please share it. Send it to myself. Send it to go out to the AFCI. Submit that as a statement or whatnot, and provide your contact information. We would love to raise the awareness of the good things that these technologies are doing. So,
Great, thank you, Tom.
All right. The other thing I do want to say too is, and I had it here, electrical fire statistics. NFPA has interesting reports on electrical fires. They publish data on home electrical fires. So what I just did was I searched for electrical fire statistics and found the one that had a National Fire Protection Association, but that's all a part of their research foundation. And what's really interesting, Ashley, is that when you look at the statistics and the data associated with the home fires involving electric failure or malfunctions, we're seeing a steady decline of the number of electrical fires in these applications. And it's hard to even, like on Gfcis, it's hard to directly say it's because of AFCIs. It's hard to directly say that the shock reduction is directly related to Gfcis because, I don't know, Donnie, you're probably similar age that I am. And when we were kids, we had those drills that were all metal, right? And I know, and on our job site, we always had that one drill that it was a family run type of thing, business. So we had the cousin who would come and visit and help for a weekend. We'd tell him, hey, we need you to take that drill and drill some holes over here. And when we would sit back and watch him, because as soon as that cord would jiggle, we'd watch him just get a jolt and drop the drill. And we thought it was funny at the time, but it was dangerous. We could have killed somebody, but we just got a kick out of it. But you can't get those drills like that anymore. They all have the plastic. They're all double insulated. All of your tools are double insulated. So the entire industry is changing considerably. Technology is going. And what you guys and gals are doing over at Siemens is doing the same thing. We're taking technology to the next level. And in partnership with good contractors, we can make really good, safe electrical installations with producing results like that and reducing the incidence of electrical fires for safe and good use of power in residential homes. So it's all good stuff. And I really appreciate both of you for what you guys and gals are doing for the industry. So we are coming up at 1 o'clock. Is there anything we missed?
I don't think so.
Did that hour go fast?
It did. It did. We could talk about a lot more, but yeah, I guess contact us if you have any questions. And if you need help, please reach out to the manufacturer because we want to help.
Right. Anyway, and use afcisafety.org. So it's www.afcisafety.org. And if you have any unwanted tripping issues or things like that, please register them because we look at the statistics as well. Code Making Panel 2 loves to see those statistics as well, to see the indications and what's going on in the industry with regard to the compatibility and concerns around compatibility, especially as we continue to expand. And we've expanded considerably. I never even got to the IAEI's AFCI. The AFCI expanded the slides, but we will. You know what? I'll hit that. Maybe I'll do another session next week to talk a little bit more about AFCIs and Gfcis for our next IAEI News Live session.
Fantastic.
Beautiful. Well, guys, what do you want to do? Do we have any parting words? Ashley, I'm sure you want everybody to buy a Siemens product. I know you do. And of course, right? So, and you want them to reach out to you and your contact information. Is that something, do you want to share? Is there if somebody wanted to, I don't know what you want to share on YouTube, but if people get in contact with me, I can definitely get you in contact with Ashley, or you can go to the afcisafety.org website. And
I think that's the best way because anything that comes through there to Siemens will come to me. So that's
perfect. That's perfect. Excellent. Donnie, any parting words of wisdom and encouragement?
Well, no, thank you so much for having me today. It's been a pleasure to sit and talk about these topics with you guys, and definitely excited about this new product from Siemens. And it's a pleasure to be here. Thank you.
Awesome. And I love the train in your background.
Thanks.
That's cool.
That is cool. So you a Lionel or a Mike's Trains fan, or are you not sure?
Not quite sure.
Okay. All right. I know my dad used to be he used to work on a railroad in a steel mill. So he drove the switcher. He was a conductor and used to dump cars, all that good stuff. So I think it's Mike's Trains started to reproduce the small railroads. So he worked, okay. Yeah. So you can get some really nice trains, but that's a nice picture in the back.
Thanks.
All right, Ashley.
A pleasure talking to you.
Always a pleasure here too, and we'll see every one of you at the next IAEI section meeting. Ashley, I haven't seen you at a section meeting. We got to get you there. Randy Dollar's not cutting it, and we all love Vincent Delacroix. But
I was going to say Vince comes and represents.
I know, but
amazing job.
He does an amazing job. We just had him at the West Virginia chapter, and he talked, I think it was swimming pools. So he does a great job. And thanks for supporting IAEI and his efforts and Siemens' support of the IAEI. We really appreciate that. So, and thank you. Donnie, thank you for joining us.
Thank you.
All right. And all righty, everybody. I am going to sign off. Felix is saying thanks to both of you. Vincent Cooley, he did have a question about knob and tube, but I'll try to answer him later. And Joseph Violi, thank you. And thanks for everybody for joining in. And remember, Ashley, this video is up. It's out there forever. So it's going to be on the IAEI's YouTube website. So please go up and check it out, everybody. And let's remember to subscribe. Don't forget to subscribe and hit the bell. And I know, Donnie, are you a subscriber of the YouTube channel now? Or are you going to be?
I am now.
Awesome. And Ashley, you better get over there and subscribe, sister. All right?
Yes, sir.
All right. Thanks, everybody. Take care. Stay safe. And remember, please stay healthy. Signing off.